Hey, Algebra 2. So we are learning Algebra 2. We are in Chapter 1, which is titled Quadratic Functions and Factoring. We're going to get into Lesson 1.1, which is Graphing Quadratic Functions in Standard Form. This might be a little bit of a review, but we're still going to take our time. If you look in what I posted in Google Classroom, there's a blank notes slideshow that has a little more information on key concepts. So I would like it if you look at that. In fact, if you see, this is my first slide, but if you look at the key concepts, this is what you will find in your Google slide. Okay. Parent function for quadratic functions. This talks about the quadratic function, which is a happy parabola, which we talked about in geometry a little bit, or in Algebra 1 a little while ago. So our parent function for quadratic functions is a happy parabola. Every happy parabola has a lowest point, which is the vertex when it's happy, or a highest point, which is the vertex when it is a sad parabola. The axis of symmetry divides the parabola into mirror image, the left and the right, and it always passes through the vertex. So for here, you'll see for f of x equals x squared, and for any quadratic functions named g of x equals ax squared plus bx plus c, which is standard form, whenever b equals 0, the vertex lies on the y-axis, and the axis of symmetry is going to be x equals 0. But we'll get to that in a minute, okay? Let's talk about our first example. So it says graph y equals 2x squared, and compare it with the graph of y equals x squared. For here, the easiest thing is going to be to make a table, okay? So if I make a table, I have the things I'm going to plug in, the input, which is the x, and then the output, which is the y. And we're just going to pick some values like -2, -1, 0, 1, and 2. Those are going to be the values we plug in for x. If I plug in -2 and square it, I get 4, and 4 times 2 is 8. -1 squared is 1, times 2 is 2. I plug in a 0, I get a 0. I plug in a +1, I still get 2 for my output, and I plug in a +2, I still get 8 for my output. Okay, so that's what we're going to do first, is make a table. Then we're going to go ahead and plot those points. Okay, didn't mean to do that, but I've got 0, 0, and I go -1, +8, which isn't even on my graph. Sorry, -1, -1 is +2, 1, 2, which is right there. And then -2 is +8, which is right there. And I reflect that over the axis of symmetry, and my red line is y equals 2x squared. And then I would draw a smooth curve through those 5 points. It's very difficult for me to draw a smooth curve, as you can tell. All right, and then I would compare that to y equals x squared. And if I did another table, oops, oh gosh, I didn't want to do that. Sorry. Undo, undo, undo. There we go. Getting used to my new tablet. If I plug in the same points, -2 squared is 4, 1, 0, 1, and 4. So this is y equals x squared. Here we have y equals 2x squared. Okay, that would be the blue graph. And this one is skinnier. Is that how you spell skinnier? Thinner. Oh gosh, I don't think there's 2 N's. That's awesome. Great speller. So if we compare them, they both open up. They both have the exact same vertex and the same axis of symmetry. So we can write same vertex and same axis of symmetry. Cool. All right, let's try another one. think that's going to be the same. Yeah, we don't need that page. So here we have example 2. So now we have, we're graphing in the form y equals ax squared plus c. We just finished graphing in the form y equals ax squared, right? So here, let's try this one. And we're going to do the same thing. We're going to make a table. Our input and our output. I press the button again. Okay, so for our input, I'm actually going to want to pick numbers that are divisible by 2 and get a little bit smaller. So let's just do, I don't want to do ones. No, we don't want that one. My face is over the erase. Oh, erase. Looks like I just erased my face. Aha. Sorry, I don't know how to. There we go, I think, yeah. All right, let's try that again. I'm gonna pick numbers that when I work through them are divisible by 2 because I have a 1/2 out there in front. All right, so -4 squared is +16. Divide by 2 is +8, but I have a negative out there, so that's going to be a -8. Oh, -8 plus 3, which, I turned off my face again. -8 plus 3 is going to be a -5. It's going to be a learning curve for me. -2 squared is +4. Divide by 2 is +2, but there's negative out there, so -2 plus 3 is 1. And you guys can totally do that on your own. And then I'm going to reflect that over the x-axis. So I'm going to have a +1 again and a -5. All right, and if I graph that, what we see here is, let's see, get a different color. I'm going to have to move my face. That's fun. I just need a different color. So this right here tells me that it's a sad parabola. And this right here tells me that we are no longer at the vertex, but we have moved +3 on the y-axis, which is why our vertex is right there at 0, +3, which means this value is wrong, and I didn't notice it, sorry. So if I go to a -4, and this goes by 1, 2, 3, 4, I go all the way to, let's hide that, this value, -2, x equals -2, y equals +1, 0, +3, 2, +1, and 4, -5. So we are an unhappy parabola where the vertex shifted up by a value of 3. Let's see if there's anything else. Nope. And we're comparing that to the same y equals x squared, which the vertex is at 0, 0, and it's happy because there's it's positive out front, it's not negative. So that's how we're comparing it. All right. And we don't need that page. Now there's always some guided practices. We do a few examples and we do a few guided practice. Guided practice are just practice before you get to the homework. So if we look at number 1 for guided practice, again, oh, I'm still in green, I thought I switched it. I'm gonna set up just a little table here. And -2, -1, 0, 1, and 2. If I input -2, squared is +4. +4 times -4 is -16. -1 squared is +1 times -4 is -4. If I plug in a 0, I get a 0. And then I'm just going to reflect that over. And if I graph that, that's what I have right here. -1 goes to -4. 0, 0. +1 goes to -4. And I can't graph the values -16, but we see that our vertex is at 0, 0, and we're unhappy because we have a negative out front right there. If I compare that to y equals x squared, that's a happy parabola, and it's a little bit wider. Okay, let's try the next one. Here, okay, I should be able to ask you, is this a happy parabola or a sad parabola? That tells us right there, it's unhappy. And this tells me I'm going to shift 5 down, which we already see. Oops, we already see there. I wish there was a little undo button. I don't see it though. Okay, we're shifting straight down. So if I set up a table, x, y, -2, -1, 0, 1, and 2. -2 squared is +4, but there's negative out there, so -4. +1, negative out there. Oh, I forgot to subtract it again. If I subtract 5, -4 minus 5 is -9. -1 minus 5 is -6. 0 minus 5 is -5. And then 1 squared, negative again. We're going to get the same values again. And if I plot those, for -1, I'm doing -6. So -1, -6. 1, +6. Sorry, +1, -6. And I can't graph the -9s because my graph doesn't have enough space. But if I compare that to y equals x squared, -1, so 0, 0, -1, +1, +1, +1, it's going to look something like that. Okay, cool. All right, I'm going to skip this one. It's the same type of problem. I've actually shown the answer here for this problem, so you can always check your work. And if I'm comparing it to y equals x squared, -1, +1, +1, +1, then 2 is going to go to 4, 1, 2, 3, 4. And if we notice, this is y equals x squared. Okay, this one is wider. And that is because I have a fraction out front. We'll get into some more practice like that as time goes on. All right, next example. Look what we have now. It used to just be in the form y equals ax squared plus c, but now we have a b in there. And we talked about at the beginning that having b equals 0 means we're on the y-axis. We're no longer on the y-axis. In fact, in your notes, you'll see where is it? There we go. You'll see this page. So properties of the graph y equals ax squared plus bx plus c. Over here we look, when a is greater than 0, we have shifted. We are a happy parabola. And the vertex is at the x value of -b over 2a. And we're going to get those values from a and b. We're going to plug them into this little equation right here, and it'll tell us where our vertex is. Here we have when a is less than 0, we're an unhappy parabola. And we're still going to find the vertex by -b over 2a. So the characteristics of this graph are the graph opens up if a is positive, down if a is negative. The graph is narrower than the parent function if the absolute value of a is greater than 1. And it's wider than the parent function if the absolute value of a is less than 1. This means if a is a whole number, and this means if a is a fraction. Then the axis of symmetry is x equals -b over 2a. It's the axis of symmetry. It's always the line x equals a value. And then the vertex has the x coordinate of -b over 2a. Then we would plug that in to find the ordered pair, but it's okay. We'll do that in a little bit. But the y-intercept, which is very important, it's right here. The y-intercept is that c value, okay? The c value from your equation. that C value becomes our y-intercept. So let's go ahead and practice. All right, so here we have a function of the form y equals ax squared plus bx plus c. All right, so first let's identify the coefficients of the function. I have a equals 2, b equals -8, and c equals 6. Okay, let's use those. First I'm going to find the vertex. And I said we find the vertex, calculate the x-coordinate. X equals -b over 2a. So -8 over 2 times 2, which is +8 over 4, which is the value 2. And then find the y-coordinate of the vertex. Let's go ahead and plug that in to the equation. We have the x-coordinate, it's 2 squared, 2 plus 6. So 2 times 2 is 4, times 2 is 8, minus 8 times 2 is 16, plus 6. Let's see, I'm going to add 8 plus 6 first, and that gives me 14. 14 minus 16 is -2. So my vertex is the ordered pair 2, -2. So if I plotted that point, I believe I've got that on my next slide, but it's okay. I'm going to go +2, -2. That's my vertex. We know it opens up because A is a +2. Let's draw my axis of symmetry. It always goes through the vertex. My y-intercept is 6. It's right up there. And then that will reflect over the axis of symmetry. So if I'm 1, 2 away from the axis of symmetry, I'm going to be 1, 2 away again, equal away. Oof, that was bad. I do wish I had an undo. I'll have to find that later. So our y-intercept is 6. Everything is there. So we can always evaluate the function at one more value, and I'm going to evaluate it at 1. So we can have y equals 2 times 1 squared minus 8 times 1 plus 6. 2 minus 8 plus 6. 2 minus 8 is -6, plus 6 is 0. So I can get one more point of 1, 0. It'll be right here, and that will also reflect over, oh, that was such a bad drawing, to there. So really that should, oh my gosh. That's terrible. You see the point though. So we've drawn a parabola through those points and everything is grand. And here you'll see everything drawn much better. So we have our vertex, which we found. We have our y-intercept at 6. 1, 2, 3, 4, 5, 6. We reflected it over. And then we plotted one more point at x equals 1 and reflected that over. And another slide for the same thing. Let's try another one. So let's graph this function. Oh, this is guided practice. So here we're just practicing the same thing again. So let's find a equals 1, b equals -2, and c equals -1. We know this is a happy parabola. So let's find our vertex. Our x value of our vertex is -b over 2a. -2 over 2 times 1. That's +2 over 2. Just plain old 1. And we can find the y value that goes with that. 1 squared minus 2 times 1 minus 1. 1 minus 2 minus 1. 1 minus 3 is -2. So our vertex is at 1, -2. That is our vertex. Our axis of symmetry, so we plot the vertex, 1, -2, and we draw the axis of symmetry through the vertex. The y-intercept, is -1 right here, and we reflect it over. And then we plot one more point, and let's just do, we already have x equals 1, so let's try x equals 2. 2 squared minus 2 minus 1. So 2 squared is 4, minus 4 minus 1 is -1. So one more point would be 2 comma -1. So if I go over 2, 1, 2, -1. We already have that point. And if I reflected that over, it would be right here. So that was a bad choice on my part. Okay, let's try 3. 3 squared minus 2 times 3 minus 1. So 9 minus 6 minus 1. 9 minus 7 is 2. So it would be ordered pair 3 comma 2. 1, 2, 3, 1, 2. And then reflect it over. So I'm 2 away from the axis of symmetry. I can go 2 more. And then I can draw my parabola. Okay? All right, you guys should be able to do this one on your own. I don't know how to pause it though. 2, 6, 3. So our vertex, we can find our x value first. Negative b over 2a. Negative 6 over 2 times 2. So negative 6 fourths, or negative, simplify that, negative 3 halves. Let's not do that. So that kind of stinks. If I put that in for my values to find the y that goes with it, a little bit messier. These cancel, I'm left with negative 3. Let's see, 2 goes into 6 3 times, minus 9, plus 3, so a negative 9. So my ordered pair is negative 3 halves, negative 9, which doesn't seem right. Number 5. It's not. X value is negative 3 halves, which is correct. And somehow I've made, oh, I didn't square this. That would be my first mistake. So that would be 9 fourths times 2. Negative 9 plus 3. So 9 fourths times 2. This would be 9 halves minus 9 plus 3. Let's see, that would be 9, 8, 7, 6. 9 halves is the same as 4.5 minus 6 is negative 1.5. So negative 3 halves, negative 3 halves, which is what we have here. All right, so we found the vertex. That took a while. We need to find the y-intercept, and I'm still in green, is 3. So I plot the vertex. I plot the axis of symmetry. I plot the y-intercept. I reflect that over. And then I can find one more point. This is already taking a really long time, but I have enough to graph my parabola. Cool? All right, we have our first unhappy parabola. But I'm not going to do another example for you. I think that you guys have got it from here. First, we find the vertex, then the y-intercept, and then another point if we need one. And then graph it. All right, I believe in your notes there is, another key concept. Let's go ahead and look it over. So here we have minimum and maximum values. So for your equation in standard form, the vertex's y-coordinate is the minimum value if it's a happy parabola, or it's a maximum value if it's a sad parabola. It's just the y value though. So here I have a happy parabola, which means I have a minimum. That means that my y value is the minimum, because if you look at the y-axis, that's the lowest point. The x-axis doesn't have anything to do with the lowest point, just the y-axis, because it's the one that goes up and down, the vertical axis. Okay? All right, let's finish this up. So tell whether the function y equals 3x squared minus 18x plus 20 has a minimum or a maximum value. Okay, we know that a is greater than 0, therefore it's a happy parabola. It opens up. So we are going to have a minimum value. Okay, now we have to find the minimum value. All right, I'm going to add another video onto this to show you the graphing calculator, but right now I'm going to go straight to Desmos. And I'm going to type this in, make sure I have it in front of me. Type this in, y equals 3. You guys can practice this along with me. 3x squared minus 18x plus 20. I'm going to move this around, and we knew that it was going to be a minimum, but on Desmos, all I have to do is type it in, and I see that my minimum is 3, negative 7. Now, which value is the minimum? It's just the negative 7. It's the lowest y value. So if we look right here, let's see. Using our graphing calculator, we found that, but it's just the y value. The minimum is negative 7. And then our last example. So a go-kart track has about 380 racers per week and charges each racer $35 to race. The owner estimates that there will be 20 more racers per week for every $1 reduction in the price per racer. How can the owner of the go-kart track maximize weekly revenue? So if we're maximizing something, that means that we're going to make a parabola that opens down and find the top of it, the y value. How do we do that? All right, let's figure it out. This is a hard one. All right, so the first thing, let me get to a black marker. The first thing I'm going to do is talk about revenue is what we're trying to find. And revenue is going to be equal to the price in dollars per racer times the attendance. And I always spell attendance right, and I just did. It's one of those words I can't get straight in my head. It's A-N-C-E at the end. So revenue is always an R value, and it's a function, so it's revenue evaluated at X, and that's going to be, they said, $35 to race per week, charges the racer $35 to race. The owner estimates that there will be 20 more racers per week for every $1 reduction in price. All right, so price, we're going to reduce it, and we have 380 racers per week, and we think we're going to increase it by 20. All right, that's what we have. Now, that is an amazing equation. So the first thing we're going to want to do is FOIL it. Okay, 35 times 380. I've already worked it out on my paper, so I didn't have to try to do this. So first, outer, it's going to be plus 700x inner minus 380x, and then last, minus 20x squared. Okay, that's not in standard form. Standard form, I need to go the opposite order, which is good because I needed a negative a term. Let's see, I'm going to do plus, add those together, and then plus 13,300. All right, so that right there is my equation. And I'm going to grab that equation and put it into Desmos. Y equals, let's see, negative 20x squared plus 320x plus 13,300. Way too big. I'm going to zoom out. But I'm looking for a maximum, so I need to go up here. Oops, didn't want to do that. All right, I have to move my face again because I need the wrench. So I want my x-axis to be, let's see, my x-axis is not right. Let's see. Not having good luck, am I? Oh, for goodness sakes. That's why. You guys have probably already figured this out by now. Let's do negative 5 to 10. And my y-axis, 0 to, there we go. Found it. 8 comma 14,580. So that, what does that mean for our answer? Okay, we're trying to find the maximum. We found the maximum was 8 comma 14,580. The maximum is always the y value. So that means that that's the maximum that they are going to make. How can the owner of the go-kart maximize weekly revenue? So the vertex, which means the owner should reduce the price per racer to $8, which is the x coordinate of my vertex. That means that they will make revenue $14,580. Right? That was a tough one. Okay, coming up with that equation is the worst, and we are going to do that more and more, and it'll get easier and easier as time goes. So here, find the maximum. Go ahead and type that into Desmos, and I'll give you the answer so you can check. The y value would be did I say maximum? That says minimum. Because it's a happy parabola, it has a minimum. So we are at negative 19 for our y value. And then the last one, what if in example 5, suppose each $1 reduction in the price per racer brings 40 more racers per week? It just means that our equation would be 35 minus x, 40 more racers, 380 plus 40x. And actually, I should say, you can type it into Desmos just like this, and we will get our revenue. How can weekly revenue be maximized? So here our vertex actually works out to 12.75. Oops. 12.75 comma 19,802.5. So that means the owner should reduce the price per racer by $12.75 to increase the weekly revenue to $19,802.50. Okay. All right. I'm going to stop this video and go to the next one. Okay.